In the next hour and 30 minutes, you'll see Jose and I solve some common, maybe not so common for today, but good LeetCode problems in which you get to see our raw thought process, how we tackle problems, and kind of just how we go about in our problem solving techniques. So stick around. And then also to the end, you'll have a Q&A where we answer some of y'all's questions. And then also in the middle of the video, we'll have an article in which we talk about what's going on in the news. So Jose, without further ado, you ready to get this show started?
Yes, sir. I'm ready to get into it.
Perfect. Before we start, we just want to give a shout out to our channel. We do a weekly coding show every Wednesday at 8:30 p.m. Our most recent upload is this one right here that you can watch. And unfortunately, there was a little error that happened, and we just want to say we're sorry. But as for proof, we do have the video right here that we recorded last. When did we record this, Jose?
Last Wednesday, which is. Let me confirm.
Yes, last Wednesday. We recorded
the third.
The third. We recorded this on the 3rd, and we spent an hour and 33 minutes on this. Me and Jose went through some problems. We reviewed an article. We went all the way and solved another problem. We did so good. It was like one of our best videos, not gonna lie. One of our best times where we solved these problems, and it was very good. And what do you know? At the end, look, there's audio. Audio's all the way up. At the end, there was no audio whenever we started editing it. So we're very sorry about that. That's why we're gonna try to make it up for y'all in this episode. What we're gonna be doing today is we're gonna be doing some recursion problems. All right, something that maybe most people try to go away from, but recursion can be difficult sometimes. But today, as a punishment, me and Jose, we're gonna try to tackle them, see how many we could do, and that's about it. Jose, any thoughts? What do you want to say?
That in Paris is 7 hours ahead of us, and then Tokyo is 15 hours ahead of us. Just fun facts, throwing it out there.
Okay.
So, yeah, I think right now it's 9 p.m. in Paris. Pretty cool. Like, damn, bro.
Well, man.
They're zooming over there, bro. But yeah, other than that, bro, yeah, I'm good, bro. I'm ready to begin. I know we got an article. We got some problems. Recursion, but it's a different type of recursion. So that's gonna make it a little bit fun. So that's gonna be fun. It's gonna be challenging. We're gonna be exploring new topics, and we're gonna be exploring backtracking, which sounds scary, but it's a lot of fun, bro. Trust me, man. Trust me, it's a lot of fun. You're gonna have fun.
Okay.
And on that, we're gonna, I'm excited, bro. I'm excited to get into
this.
this.
One last thing before we get started. Shout out to HEB, by the way. I'm repping HEB apparel right now.
Ooh,
shout out to all my brothers and sisters at HEB. Y'all are amazing. Y'all are great. This is not a sponsorship, but I really like HEB and everyone that works there. So shout out to HEB. Without further ado, let's get started. Jose, you want to read it or you want me to read it?
The problem, we're not doing article. Oh, we're doing the problem and then the article. Okay. Yes. Give me a second. Let me see. Yeah, cause I have it on my other screen. We got problem 136, single number. This is an easy problem. It says the following: given a non-empty array of integers nums, every element appears twice except for one. Find the single one. Find that single one. You must implement a solution with a linear running time and use only constant extra space. That is interesting. That's why I like this problem, because it's gonna make us think a little bit, but not too much. Just a little warm up. Example 1, we got input nums 2, 2, 1, output 1, because 1 is the non-repeating one. Example 2, we got 4, 1, 2, 1, 2. In this case, it's 4 because it's non-repeating one. And example 3, input nums equals, we get 1, output 1 because it's the only one out repeating. But yeah, that's pretty much. I like it. It sounds interesting. It sounds a little bit challenging, but I think it's a really good warm-up to turn on those gears and see how far we can take it.
Okay.
What are you thinking, my guy? What are you thinking?
You must implement a solution with the linear runtime complexity and use only constant extra space. So constant extra space means
O of 1.
O
O
of
of
1.
1. I think, if I'm mistaken, dictionaries are of O of 1.
Okay. Every
I'm not
element
mistaken.
appears twice except for one. Find that single one. Linear runtime, which means O of n, yay?
O of N. Yeah.
O of n. So we could iterate through the list and use a dictionary to search to
Wait.
see if it's...
I just confirmed dictionaries are not constant space.
They're not constant space.
Sorry, not constant space. Yeah, I apologize for that.
Okay, so...
It is interesting. It's like a little puzzle. It's a little puzzle.
Okay.
But hey, we're here to nerd it. We might need to use some inspiration, but you know, we'll see.
All right then. So, so when it
Linear
says
runtime.
linear runtime,
Okay.
that means we can iterate through the array. Yay?
One time.
One
Just
time, just
yeah.
once.
Yeah.
But we gotta keep track of something, some way, in which we're only using constant extra space. Are you sure? When it says constant extra space, it doesn't mean like dictionary?
Wait, let me see.
Because that...
The amount of addition memory and algorithm used is a fixed amount and does not grow with the size of input data. So it's like fixed. It doesn't move or there's nothing. But with a dictionary, you do increase depending of n. Because you keep adding. So that's what's it called? Linear. Right.
I see
That's
what you're
it.
saying. I see what you're saying. That makes sense. But the lookup time is constant.
Yeah, lookup time.
Okay.
Yeah.
Okay.
Yeah, I got confused with
that's
those.
where we got confused then. Okay.
Yeah.
Constant extra space. So that means we need to stay with... We need to just have like a variable tracker or something, or like...
Ooh.
What does that mean? Like I'm trying to remember. Constant extra space.
Damn, bro, this one is a tricky.
They're not sorted, right?
No.
Let's look at the constraints. How about that?
Okay. According to these, we're gonna have at least one number. Right. The length of one number, and the numbers inside the list can range from -3 times 10 to the power 4 all the way to less than or equal to 3 times 10 to the power 4. Each element in the array appears twice, except for the element which appears only once. Ooh, fast. This is a interesting one.
Wasn't there a trick one time that a viewer suggested back in our streaming days?
Okay.
That gave us constant space. I thought it was like something like... I honestly, I don't know, but I'm trying to remember.
I don't remember that one.
There was like a really good trick. Maybe it wasn't related to constant space, but maybe it was... Okay, what were you gonna say?
I was gonna say use two.
Can we look at the topic?
Yeah.
Ufas.
Bit manipulation. Damn, I didn't know about that. But my idea is two for loops, right? That's 2 of n. In linear time and stuff, we drop the 2 and we just keep the n, which is linear time. So what we can do is use one for loop to sort it, right? Sort the numbers. Another for loop to have a 2-pointer approach. Oh, that wouldn't work though. Yeah. Because, yeah, the 2-point approach wouldn't work. my way, because I was thinking 2 pointers, then we can just like compare the one in the left and the one in the right, and continue on, continue on, continue on. But that wouldn't work. Oofas, bro. What did I do? What did I do? All right.
I'm still thinking.
Still thinking.
What's bit manipulation?
Honestly, bro, I've seen it a lot, but I'm not sure. Let me search it
Yeah,
out.
let's search that one out. Let's get some more info on that. Y'all let us know, if y'all are still watching right now, let us know what are y'all thinking. Like, what's your initial thoughts? If you solved this problem before, let us know what you did. If you haven't and you kind of like working it with us, let us know like what are you thinking. Because right now, that's kind of what we got right now. We got those two things. It needs to be, the space needs to be constant, and then the solution needs to have a linear runtime complexity. Jose, what you got?
So bit manipulation is a process of directly manipulating individual bits of data to perform operations. This technique uses bitwise operations like AND or XOR NOT and shifts to perform tasks such as data compression, encryption, error detection, code optimization. It is a powerful method for improving performance and efficiency in low-level programming, cryptography, and networking. So fast, bro. Okay.
Is there any hints?
No hints.
One hint.
One hint. Let's see.
Okay. Think about the
XOR.
XOR operator's property.
Dude, this is something we've never done before, bro.
XOR. Wait a minute.
Let me see XOR truth table.
Wait a minute.
Oh.
Remember, you compare two numbers. Yes, got it.
Okay.
You compare the two. Wait, no, I don't got it. Or so. Okay, look. You compare the two arrays. You duplicate it. Okay, I don't know if this is true yet. The two arrays. Never mind. That makes no sense. Wait, Jose.
Okay.
Nah, never mind.
Listening.
You compare. Okay, we know. We need to compare. We need to use the XOR operator or something along the lines.
Yeah.
Right?
Yeah.
So that means we need two things to compare, right? I remember in classes, you stacked them up. You stacked up the numbers on top of each other. There was one list of numbers and another list of numbers, and then you do the calculations. XOR is saying if they're the same, if they're not the same, that's a 1, right? What's the truth table?
Yes. If they're not the same, they're 1, and if they're both the same, they're 0.
Okay.
I can write it down for you.
So how is this relevant to this? I thought I had something.
Okay. Think about it. Oh, because it is interesting. Yes, okay, fine. You figure out XOR if they're equal, if they're not equal. But how do you keep track of what number is a single number, you know what I'm saying?
Okay. Can we go into the discussions? It seems like we're a little bit stumped here.
Yeah, well, I'm down to the discussions. Let's see. Oh, we got a picture in the first pose. Okay, so we got 2 and 2, 1, -1. We got 1 0, 1 0, 1 0, 0 0, 0 0, 0 1, 0 1. Okay.
What?
So in the next one we got 4, and then we get the 1. We XOR with the previous one, and then we get the other one.
Oh, you get the previous one. And then
So whatever you get at the end, that's what you have. That's what you're gonna get.
Wow, how do people come up with that? How does that work? Oh, I guess
because they cancel out, like the 1 and the 1 and the 2
like
and the
that.
2.
They cancel out, so then the. Well, I don't know. Well, that makes sense though. I mean, I don't know the theory behind that just yet, but I understand what they're doing. So I guess.
And I think it.
Keep going. What are you saying?
And I think it is the fact that they're canceling out each other. For example, the XOR with the zeros, that's 4, and then we XOR the 4 with the 1, and we get 1 and 1, and then with the 2, and we get 1 and 1, and then the second one, right, cancels out the 1 that it put. So now we got 1 1 0, and then the 2 cancels out the 2 that we added, and now we get 1 0 0. So that's, I think that's the what we're trying to do here. I believe so.
All right then.
Alrighty.
How?
Okay.
Do we do such thing?
So I'm pretty sure we can do with a for loop.
Okay.
Where I is we have I for loop. Then with that for loop, we're gonna say XOR I with XOR I with variable. XOR with XOR I
with 0
with variable. Oh yeah, and wait. Ooh. I'll let I know. XOR var, and we equal it to 0 at the beginning. Yeah or nay?
XOR I with yes.
And this goes before the for loop.
And then
and
update.
And then update XOR var with new XOR results. Yes.
Mm-hmm.
And then at the end, return XOR var. Yeah or nay?
Yeah.
Yeah? Okay.
Now what?
You want to cut it up?
What's the? How do we change it to a bit?
I think it does. I think it does it by itself already.
Okay.
Yeah. I think we can do 4 XOR 4.
I'll let you write it up.
Alright, I'm not sure how to do on Python. How to even do the XOR in Python. Okay, I see. Okay, so we're gonna get XOR var which equals to 0 for I in range length of nums. Right. You're gonna set XOR var with I with nums at position I. We're going to, if I'm not mistaken, this symbol. And then with that, maybe?
No way.
Maybe? I think so. According to this picture, that's what I think we're doing.
Okay, can I run it?
We can run it.
Let me see.
Oh.
I think that's pretty convincing already.
That is pretty convincing.
Should I submit?
Let me see. Let me double check.
Okay.
Let me see if there's any test case, but I don't think there is. So we might need to wing it. Yeah, I don't think there's any test cases.
Should I submit it?
You want me to submit it first?
No.
Okay. Submit
Really?
it. Yeah.
Submitting it. Let's go.
Let's go. It was.
Good stuff, man.
Bit manipulation. Honestly, bro, that is interesting. Very interesting.
That one's tough because like, how would you know that? Like, how would you?
Yeah.
I guess just maybe you run into the problem one time, you search it up, then you remember it for future reference. Maybe. But it seems like you would only need to use this trick when you only need one variable to store, like to track.
Yeah.
To save some space.
Mm-hmm.
Which that's a really interesting trick right there.
Mm-hmm.
I wonder, and pardon my lack of knowledge, but I wonder if this is very common when it comes to like low level hardware coding.
Mm-hmm.
If stuff like this to reduce memory, if they have to do like bit manipulation.
Yeah. Damn, bro. That's a question. I like that.
All right, folks. If you decided to watch through that grueling first problem we just did, we want to lighten it up now, and we want to go into our article segment, in which we just find the up and coming major breaking news article and we discuss it, give our opinions, and we encourage y'all to give your thoughts in the comments as well. So before we get into our second problem of today's show, we're going to be going into that segment. All right. So without further ado, let's go into that. Oh my, do we have this striking article.
Damn, that is crazy.
Article says, Disney strikes $1 billion deal with OpenAI. Rachel says Disney will invest $1 billion in OpenAI and will let the ChatGPT maker use its characters and properties in a limited capacity as a part of a 3-year licensing agreement. So they announced this Thursday, which is today, and under the deal's terms, users of both Sora and ChatGPT will be able to generate content featuring characters from Disney, Marvel, Star Wars, and Pixar. And then, of course, the Disney staff could use OpenAI's tools to create new products. That's very interesting. So, separately, blah, 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 they sent a cease and desist letter to Google. Anyways, Jose, I'm gonna send it to you first. What are your initial thoughts on this? What's your take? What are your initial thoughts?
Honestly, bro, hopefully they don't use my own. It's okay, you know, everybody's using OpenAI and they can use it, right? But I just don't want Disney to start using OpenAI or AI in general to make their movies, new characters, storylines, their own productions and stuff. Because that's where, like, movies become sloppy. What's it called? The script becomes sloppy. The design of the characters becomes sloppy. The stories become sloppy. So I think that's my only like, damn. Hopefully Disney doesn't go that route. Because I've seen a couple. I think it was Coca-Cola that made AI advertisements or AI commercials. And they were bad. They were bad AI. Like, you could tell there were AI stuff, and wasn't good. So hopefully Disney doesn't go to that route. And I'm interested in what they mean that GPT will able to generate content featuring characters from Disney. Like, probably like now, like, users can create their own pictures with Marvel, Star Wars, create their own movies with their Disney, alternate endings to different like Disney, storylines and stuff. So that's gonna be interesting. That's gonna be interesting to see how they play around. But yeah, that's the only like thing that I don't really want, is that to Disney incorporate AI into their productions of films, movies, series, characters, all that stuff. What do you think though? What do you think?
I agree with you. I think there's a fine line between like what's acceptable as AI generated content, because I mean, from speaking from our experience, more specifically for me, when it comes to creating thumbnails, it's very hard, especially if you're not an expert at it, or you don't know the best way to create a nice, engaging, or like good thumbnail for viewers to choose, right? So what did I do? I was like, well, maybe AI is smarter than me to create a thumbnail for me. And we did it for a while, where we created like AI thumbnails for our streams, and they look good, but like you just know it's AI. There's like a stigmatism on it, like, oh, you used AI and stuff, whatever, right? Yeah. And I agree. Like, I think there's like a weird like feeling that people get whenever there's AI content. I don't know whether it's because like you're using AI, and it might have some, you might make people's jobs, like our actual thumbnail creators, you might make them lose jobs because you're using AI, or maybe it just doesn't look good, or I don't know. But there's like this underlining or like fine line that people like don't like AI content right now. Yeah. Maybe because they see it a lot, people try to do it and they don't do it good, or whatever the case may be. So that is scary. Not scary, but worrisome that Disney staff will use the tools to create new products. But what those products might be, we don't know. It could be advertisements. It could be small little things for like their physical attractions, like their amusement parks, right? They might do some like banners, like animated banners using AI or something, and maybe people won't even realize it's AI. But of course, if you're doing a video that's AI or anything like that, people could probably realize what it is, it's AI and stuff. And it kind of reminds me of, like, you mentioned alternate timelines and alternate all that stuff. Like, people could create some content like that. It reminds me of that series, the Marvel What If. It was on Disney Plus.
Oh,
like
yes.
I've never seen it, but I know it was like good, it was like animated or something. Animated and like, Yeah. So, but that's crazy. Disney's Disney, out of all companies, they're very particular with who has access to their characters. Who's able to use it and like stuff like that, right? So Disney putting money and creating this deal in which it allows AI to use their characters and some properties, like, that's a big deal.
I think Disney just wants to like jump in that AI train. So maybe they're trying to give up some little sum of the rights to be a part of the AI train and take leverage of that. But yeah, like you said, bro, Disney is really very stingy, very like very careful with like Marvel, especially. Like, nobody can touch Marvel because it's Disney and stuff. So yeah, man, it's gonna be interesting. It's gonna be interesting.
Damn.
Yeah, bro. Move fast.
Let's see. Let's go back to our faces. Jose, let's just chat a little bit just about us.
Okay.
Let's
Yo,
tell
bro.
our audience
Man.
what we've been up to, how we've been before we get into our next problem.
I'm happy. I'm happy because I got my finals done today. I'm just waiting for one test to come back. But I'm happy I finished them. You know, I'm happy to like get that out the way. You know, December's coming in. Oh, baby, I'm enjoying it, bro. I
need December 20th to come faster.
Oh, about 9 more days, bro.
I need December 20th to come faster.
9 more days, brother. Hold on, bro. But yeah, bro. 9 more days, dude. Ooh, fine, bro. You know, you're gonna see Carlos like in the new whip. Ooh. You know. Nah, but dude,
I don't know about that.
We're gonna see a different Carlos upcoming in the upcoming videos. But bro, I'm excited for the December. You know, I'm excited for tomorrow because I'm gonna hang out with you and some of the friends. So yeah, bro, I'm excited. I'm just happy, truly happy right now. What about you, brother? How's it going?
Dude, I feel good. You know, finished school, right? Graduating, all that good stuff. So. I feel great. A big relief. Big relief, dude. Like, imagine going to school for so long and now, like, you don't have school. So
that is so true. You've been in school for like,
Whoa.
Hey, what you mean, bro?
So anyways, being in school for so long, you know, finally getting out.
Bro, you built the school, bro.
It's almost like, what do you do now? Like, what is it? Yeah, especially right now. Like, especially right now, there's nothing to do. Nothing at all.
Yeah, dude.
And like,
bro, let's hop on some more Battlefield 6.
And I'm down to play Battlefield. I'm down to play Battlefield 6. We could play. I've been playing Arc Raiders and it's fun, but there's sometimes I get tired of it. And also, I'm not as young as I used to be, where I get to play where I could play games a lot. Like, my brain wouldn't get overwhelmed, if you will, or like tired. Like, I would play constantly. Like, it didn't matter. Like if I didn't have anything to do in my day, I would play games, right? Maybe I can't do that now because games aren't as fun, or maybe because I don't have that stamina anymore to play games that much. So then once I hit that block, and let's say it's dark and I can't play basketball anymore, now I'm like, well, now what do I do?
Yeah, so I get you.
If I had school, I would be doing schoolwork. And you know, not an excuse, but that's why sometimes I didn't turn in assignments very early, because I would always want to make sure I had something to do afterwards, after I did all my fun activities. But
see, it's pushed it up.
Push it up. It's not procrastination. It's smart time management.
I'm gonna leave it over there. That way, once I finish it, I got something else.
Yeah, exactly. But you gotta see it. It's perspective, Jose. You gotta see it differently.
Yeah.
See it differently.
Yeah, it's a new perspective.
Yeah, exactly. So, all that to say is very grateful, very thankful, and that's about it, dude. I'm excited.
Yes, sir. Yeah,
and again, shout out to HB again. Shout out HB. Let's go. All right. Anyways, you ready for the next problem?
I'm ready for the next problem. What's the next problem?
All right, everyone. We're back into our LeetCode problem-solving environment. Let's get ready for our next problem. We have letter combinations of a phone number. And I messed up because I need to send Jose an invite real quick. So 1 second while I do that.
Yeah.
But this is a medium problem.
Yeah.
Jose, what do you think so far, just based on looking at it? What do you think so far?
It's scary because I think it's backtracking. It's a backtracking problem. I've explored backtracking problems before, and honestly, dude, they're so fun, dude, and they're so interesting. And you're gonna like it. You're gonna like it. Let me see if I can join the live thing here. It's giving me some error.
So I need to get a refresher on some backtracking. Backtracking is like recursion, but like the other way around, like from the bottom up. Like you
Not
go
quite.
all the way down and then you come back up?
Yes. So with recursion, you know, like say, let's take example the phone number. So with recursion, you go 1, and then you go 2, then you go 3, 4, 5, 6, 7, all the way to 9. But with backtracking, right? Let's say I want to try different combinations, right? Let's say I want to do 7, 8, 9, and then I want to do 7, 9. So how do I do that? So I go, once I'm at 9, I go back to 7, right? I skip 8 and I go to 9. So now I got 7, 9. So you go back and you explore different routes.
Oh, I see.
You know what I'm saying? Yeah. So that's what backtracking it's a little bit about. Also, do you mind sending the invite again? This thing, LeetCode is acting up, man.
Let's see.
It's acting up.
I went back to the other one.
Man, bro, I am hungry, bro. I'm just telling you that, bro.
Dude,
I'm about.
I ate some Chick-fil-A.
I'll be like,
I ate some Chick-fil-A breakfast today.
Baby, bro.
Yep. The chicken,
Damn, bro, must be
chicken
nice.
sandwich.
The chicken sandwich. Oh, those are good, bro. Those are good.
They're fire.
They're just so good, bro. Especially with the Chick-fil-A sauce.
Whoa.
Honey mustard, bro.
Wait a minute. Breakfast and Chick-fil-A sauce?
Yeah, bro.
I don't know. I never tried it.
You gotta try it. You gotta try it.
I think of Chick-fil-A sauce as like a lunch or dinner sauce because I usually eat it with the fries or with like an actual chicken sandwich, not the biscuit sandwich.
Try it, bro. You're gonna like it. Trust me, bro. Trust me.
I don't know. We'll see what happens.
We'll see.
I was gonna say something else. I forgot. I think we're good. Okay. I think we're fine.
Yeah. All right. You want me to read this one?
I could read it. 0.
Okay. Bet.
Yeah. So we have number 17, letter combinations of a phone number. It's a medium problem, and you're given a string containing digits from 2 to 9 inclusive. Return all possible letter combinations that the number could represent. Return the answer in any order. A mapping of digits to letters, just like on the telephone buttons, is given below. Note that 1 does not map to any letters. Okay, you got that? Example 1, we got digits equals 2, 3. So all the combinations, all the possible letter combinations that number could represent are AD, AE, AF, BD, BE, BF, CD, CE, CF. Okay, got that? So it goes.
Yeah, I got that.
AE. Okay, perfect. Now we have digits equals 2. All the possible letter combinations for digits equals 2 is just ABC, and that's what you get, ABC. So our constraints say we have the digits length will always be equal. The minimum will be 1, or the maximum will be 4. The digits length.
Okay.
And then digits I is a digit in the range from 2 to 9, inclusive. So
Okay.
I believe they're not going to use 1 or 0.
They're not use 0. Okay, perfect. Okay, yeah, that makes sense. Yes.
All right. And you want to look at the topics, or?
I'm done for the topics. Yeah.
Okay. So for the topics, it says hash table, string, backtracking.
Okay. Interesting. Okay. So pretty much, to my understanding, it's like you go to button 2, right? And you get A, and then you go to button 3 and you go D. Then you go AD, AE, AF. And then you go back to B and you go BD, BE, BF. Then you go back to 2, you go C, CD, CE, CF. Okay.
Now, what if it was 4 numbers? What if it was
4 numbers?
2, 3, 4, 5.
2, 3, 4, 5. 2, 3, 4, 5. So I'll be A, D, G, and J. Then A, D, G, then K. A, D, G, then L. Then A, D, H, J, A, D, H, K, A, D, H, L. then
A D I J
J
A D I K A D I L
I L, and then A
A
E
E G J
J
A
K.
E G K. All right,
Yeah,
nice.
yeah. I think that's the pattern they're trying to do here. So it's interesting. It's
So
interesting.
where's the backtracking coming from?
So I think the backtracking is like we got A, right? We got A. Oh, well, let's do 2, 3, 4. So we got A, we got D, then G, right? A, D, G. But then you have to go back to D, or right back to 3, and then explore H. And then once you're at H, you have to go back to D, and then you have to go to I. And then once you go back, you have to move to E, and then G, and then HI, then move back, go to F, and then GHI. You know what I'm saying?
Mhm.
So you create, I think it's like you're creating a string, A, D, G, and then once you have the string, put it up into like an array or something, and then you have to go back to create another string where you have A, D, H, and then put it up in. Yeah.
Okay.
So I think so. I think that's a backtracking problem in here. Okay. Yes, sir. Okay, so how are we feeling, Carlos? How are we feeling?
I feel good so
Gary?
far.
It's good? Okay, dude. Alright. Dude, I love I don't know, dude. Backtracking problems bring me so much joy, especially when you solve them, bro. It is interesting. Okay, so what we think now? What we thinking?
Well, we create a function, right? We wanna.
Yeah, we can create a function. Yeah.
Or do we need to create a function? I just custom like these backtracking or recursion problems as need a function, but I could be wrong.
Okay, I think creating a function will help us out a little bit because we need some parameters, some extra parameters.
And should the function return the string, the combination?
Ooh, we can. Yeah, we can explore that, and I think so. We can. I think it does. Return string of combination. Okay. So what do we want to do in this function though?
We want to.
Let's think about it. Let's see. So
wait. So first, should we create a layout of A B C D E F G H I J K L M N O, right? Because we're not given that.
Okay.
Right?
Yeah. Well, okay. We can create that. Yes.
So we could create it before the function.
Yep. Yeah. I like that. Create letter map. Yeah. And since 0 and 1 they don't have anything, right?
Yeah.
On the so we could say the first 2 elements equals to an empty array, because it's 0, 1, and 0, 1 are like the first 2 indices. That's the way I'm thinking about it. And then the second index,
so you
the second number.
So we will never touch the first index though. The 0 index.
Yeah.
Or would you,
okay.
Or would you want to just put ABC, AB, DF, and then we say 2 is the 0 index, 3 is the first index, 4 is the second? Or I'm a little bit confused.
I was like thinking something like this, where
you match 0
is empty, and then is ABC.
And ABC is index 1.
This is index 2. Because it's.
Oh, okay. Sorry. That makes sense.
Yeah,
now,
0,
this is the
1,
0 index. This is the 1, and then this is okay. Perfect. Yeah.
Yeah.
Okay.
Yeah, I feel like that way we have like it's more straightforward. You know what I'm saying? Like if the user press 3. Okay. Yes. So we create a map and we can call this array. An array. Okay. So once we have the map, I like the map thing. But once we have it, what do we do?
Well, we gotta split the digits, right? So if they're gonna give us 23, we gotta split each digit. So 2 and 3.
Okay. So we gotta split digits. Okay.
And then we start with that order. We get 2. Wait, do we split? Yeah. 2.
Interesting.
Oh, this is gonna be tough because 7 and 9 have four letters instead of 3. So I was thinking of like, oh well, never mind, doesn't matter. Okay.
But
so
no, I get you though. So we can say, okay, we split the digits, right? For example, we got 23, right? And we can do 2, 3, right? So we have 2 and 3, and we can put this like into a for loop or something like that. And then this for loop will explore 2, right? We will explore the options at 2. And we say 2, I'm not sure about. Damn, bro. I think we need some Skeletra though for this one.
okay.
What are you thinking?
Yeah,
what are you
let's go into.
Okay. So I'm just gonna prep a little bit. Let's do. So we have empty array, then ABC, DEF, GHI, JKL, MNO, PQRS, TUV, and WXYZ. So that's what we have right now. Let me pull out my other mouse. Let's see. So we get a number 23. Oh, this is too big. What do we do with this number? So let's say our 23 and our, let's call it backtracking. Right, and we get let's say number. So this is our function, and we say we can do some like fast. Should we split it beforehand?
If we split it beforehand, how would we input that into the function?
Oh,
Not saying it's not possible.
Yeah.
But I'm just curious. Because I was thinking that too. I was like, should we split it beforehand and then input it there?
Yeah.
But and also another thing with the backtracking function, are we gonna call itself?
Yeah, it's gonna call itself. Yes.
Okay.
Yeah. Oh. So what I was thinking, right? We can do an index, right? Index, which will have a 0, right? Its base value would be 0, and so we can create a for loop for letter in what is it called? For letter in is it, what's the variable called? Digit. This called for letter in map where we create where number equals index.
I see what you're doing.
Yeah, something like this. So this.
Can we turn this right into here, text?
Oh yes. We can. Let me turn that to text. I got you. So we can do. So we have. I'm gonna do index and then number. For letter in map, number, index, something like this, something like that. So pretty much, so this kind of says like, okay, give me the 2. So now this is gonna access this ABC.
Yes.
And letter is gonna go A, B, C. You know what I'm saying?
Yes.
A, B, C, and then ooh. You with me? You with me, bro? I got you.
I'm almost there, but I'm very confused how we're gonna keep going to the other digits.
Got you, bro.
Okay.
I got you. Backtracking,
No way.
tracing, index plus 1, right? Because now
You're
we
gonna
want
be
the index.
Wait.
Yeah, we want the 3. Right. Something like that. Something like that. And we pass the numbers.
I have something to say.
This is not complete though. I don't think this is complete. I think he's just like trying to like traverse. Okay, but yes. I'll let you cook. I'll let you talk.
I have something to say.
Okay. Yes.
Not saying you're wrong, but I need some extra clarification.
Okay.
Whenever you're saying index plus 1, are you assuming that the next preceding number is gonna be 1 above it? Like what if it's 2 and 7?
Well, this is index, right? This is 0 and 1. So I'm not thinking of it like, oh, it's 3 or it's 4. This can be 2, 7, and the indices will still be 0 and 1. Because it's think of it as an array.
So what's index and what's number here? I thought number was
okay.
What's this?
No, yeah, number is this. Number is this. Index is just like a starting index of where to start in the number.
Oh,
index could be 1
okay.
and we can start at 3.
Okay.
Yeah.
So why do we need index if we're always gonna start at 0 and then increment plus 1?
Oh. Didn't think about that. Well, because we need it because the index changes though. Because for the first iteration, when it were 2, indexes could be 0, we could set it to 0. But once we're with 3, right, indexes has to change to 1. We cannot like set it in stone to 0.
You could, I agree with the index.
Yeah.
But having it as a parameter is where I disagree. Could you define it inside the function itself? Index equals 0, and this is 0, and then this is plus 1.
Well, in the next call, index will get reset to 0. Because we're going other way. So the cool thing about
So would the index always be inputted as 0? Whatever you call it.
Yes. Yeah. Once we call
the first call,
way I'm thinking about it. Yeah, the first call. Once we call it over here is backtracking, tracing, 0 number. You know. And yeah. So the cool thing about backtracking is that parameters, you can use them as like a changing objects, like a state that changes right to your advantage. So that's a cool thing about backtracking. So 0, 0. Now in the next iteration, this is gonna be 1. So for letter in map, number, index, right? Which is 1. We can do backtracking, index 1, number. Something like that.
Perfect. Okay, I like this. I like this so far.
Yeah, it's kind of fun. But now we need a way to like keep track of the letters now. Which is interesting. Yeah, because we managed to like traverse right here. The first for loop is traversing A, B, C, right?
Okay. Next thing is, now that we have letter, where are we gonna use letter at?
Okay.
So that's the letter is gonna be a letter, an actual letter.
Yeah.
So we have
like A.
We have A. And then should we be passing a into a function? Should we be passing the letter down below?
Okay. We can, yeah, because we need a way to store it. You're right. Yeah. Oh man, okay. You're making me thinking here. Okay, so let's. What about we could put in an empty string, right? Let's call it temp, right? We call it temp.
Okay.
So for letter in map, we're gonna do. Okay. In letter map, number temp plus letter.
Oof.
Right. So here, I think this works. So pretty much, we're gonna do an empty list. Temp is gonna be empty. When we call backtracking, it's empty plus a
to that.
Yeah. Right. So it's
a.
It's somewhere in there like that. And then next time, once we process 3 or whatever, letter is gonna be B. So now it's gonna be empty plus B. You know what I'm saying?
Yes.
Yeah. And then next time it's gonna be C plus empty plus C. Yeah. So I think here's the nature of backtracking. You know, where you go back to the next call, you process it, and then you explore another path. But how do we get DF though? That's where I'm struggling here. Because we can't, because if we keep going letter, right, in map, if index is 1, index plus 1, that's out of bounds. So I think we need to check, no?
Well,
how you doing, Carlos? How you doing?
I'm really trying to grasp it. I'm not.
Okay.
I'm not trying to slack off.
Yeah.
This is something that I need practice in.
Yeah.
So I'm taking this opportunity as a great practice.
Yeah, for sure. Yeah. Let me know when you're stuck or you're
well, my problem is I'm trying to imagine it in my head.
Okay, I see. Okay.
Working in my head. I get it to like the first run, but then I lose the
when we reach
the line
right here
whenever we're here.
Okay, so pretty much, so the for loop, right, letter is gonna start at A, right? So we're gonna call another backtracking where index is 1, number is just the list of numbers. No, a number is 23, and the temp and plus letter. So now this thing is gonna equal
A, right?
A, yeah.
Okay.
So now next iteration, right, I'm gonna move it over here. We have an index of 1, a number of 23, and a temp of A, right? Let me correct this a little bit better. And let's assume this thing works, right? So we're gonna process it and all that stuff, right? I'm still lost in here. I'm not sure how we're gonna process once we're at 3. So index 1 is gonna tell us to use this one right here, 3 now. So we're gonna access 3, right? And it's gonna be, what is it? D, right? And then we're gonna add temp, right, plus letter, which is A plus B. You know what I'm saying? Something like that, you know?
but we need a plus d.
Oh yeah, a plus d, a plus d, a plus d. Yes. My bad. Yeah. A plus d, right? And then, right, once we have that, right, this thing is gonna go back. A plus d. Are you here up to here with me? Yeah, because I haven't figured out this thing yet.
Okay. What are you confused on with this?
No, I'm good. I'm not confused with this. I just don't know how to get the 3 and process it. You know,
Well, what do you mean process? Or how to go from
how to get
E and F?
how to get D and E and F. Yes.
Okay.
How to get that?
Ready?
So
here's an idea.
Uh-huh.
Or what are you gonna say?
Okay. No, that's why I kind of assumed that we got A and D here because I'm still confused. And this thing right here, like I'm not sure how to process through like D, E, F. You know what I'm saying?
Yes. Here's what I'm gonna say.
Yeah.
Maybe this might help.
E.
If letter, if this is the same size as the digit, that means you're done. And then we need another parameter or something on the lines where we now increment it to the next one. Something along the lines of that. Something along the lines of that.
Like a check.
Yes.
Okay.
Something, maybe that's when the backtracking happens. Maybe.
Yeah. Okay, you're onto something. Like we check if we're at the end of the number. In this case, 3.
Because if you get 2, 3, like if the initial input is 2, 3, 4, 5, the combinations are going to be lane 4. They're not going to be lane 3. They're not going to be lane 2. They're not going to be lane 1. They're always going to be 4. There's always right. So maybe that could be a way we could stop, and then figure out a way to increment to the next one, right? That might not.
Okay. I like that. I actually like that a lot. Okay. So I'm just gonna write it down here. That way we got a little bit. So you're saying if the length of temp is equal to length of number, right? Do something and return.
Yeah. We definitely want to store the letter, right? What we're going to return, how we're going to increment is going to be something.
Okay. Let me see if I can
this will
erase.
This will equal the new.
Oh my god, I erased all of this. Let me lock this real quick. Delete this. Unlock. Okay. So yeah, I agree with that. We need a way to store it. What about we got some like let's say we have a global variable called ants, which equals an array, right? Then here we put ants and we pass it as a parameter, right?
Okay, that's fine.
Yeah, and then here we do ants.append temp.
Yep.
And then we just return to the next call. Like we don't return anything. We just go back. We finish. Yeah or nay?
Yes.
Yeah. And then if I think this works actually. This is gonna be it.
How would we get to E?
Oh, okay. I see what you. Ooh. Well, we go back in
A
here.
to D. A
We
to
go.
E.
We use this for loop because now let's assume index is. Let's say we're at A, and index is 1, right? So we got A. We're gonna do a plus something. So length temp, which is 1, still not equal to length number. So we don't do anything over here. Yeah or nay? Because length is 2, right? So we go here for let in map of index 1, in this case right here, right? Get the first letter D, right? Increment the index. So now index is gonna be 3. Number, right? Number is still the same. Temp is gonna be A plus B, right?
D.
D. Yeah, I was confused. Let me see.
Why is index 3 now? It should be 2, no?
Yes, dude, I'm all over the place right now.
That's okay.
2.
That's
There
okay.
we go. Yeah. A plus D equals 2. Yes, right. If length temp this equals to length number, yes, append answer AD into append AD to answer. So now this is gonna have AD in it, right? And then this thing is gonna return back to where index back to this right here, where A is where the temp is A and index is 1,
which is
right? So now, yeah, right
okay,
here,
so now
I'm
this
just gonna go.
starts.
Yeah, the for loop is gonna go to the next iteration, right? Where letter is E. So now I got A E.
Wait.
A-E.
I don't know if it goes to AE. Wouldn't it be BD?
No, because it goes AD, AE, AF. Then BD. Oh, in this case, well, we only go back once we're here. We go to the next line. Since the next line has nothing, we go back to the for loop.
Yeah, but
because the for loop hasn't finished.
But for letter in map, the first letter was A.
Yeah, but our index is still 1 though.
And this is
because we're trying to process all the possibilities. So A, D, A, E, A, F.
I get that, but why are we on this one? Why are we incrementing that? If we were just on A and we went to the next one, right? We're on A and then we did this, right? Now we're now we're in the second call. We're only on our second call.
Yeah, the second call. Yeah.
Okay. And then we add in our second call, oh, we do this again?
We do this again. Yeah.
I see what you're saying. Okay,
what
so we go back one more time. We're still on
index 1.
Okay, I get you. Yeah.
And then letter, if the for loop still continues with its for loops, is gonna go A, D, E, F, and then
okay.
On stuff like that. Yeah.
I thought we were still at this one, this level or whatever, but I forgot that.
Yeah, we kind of.
Whenever we go here, we gotta go again. So we're on our third call instead of our second call after that. Okay, perfect.
Yeah.
Nice.
And then I think once this finishes.
Keep going.
Yeah, once this finishes, right, we're gonna go back to index 0, right, and then letter is gonna go to the B. Next letter, gonna go to B, and we're gonna process the entire thing. Yeah, and then since temp, right, is empty, and we're appending a letter right as a parameter, this is gonna get updated to empty plus B.
Yeah.
Yeah. So I think that I think that works.
All right then. I'm very excited.
How are we feeling?
I feel good. Yeah.
Yeah. It's fun. It's like it plays with your mind, but it's fun. It's fun. I think. Yeah.
All right. Let's go back to our problem, man. And see what happens.
Let's go with the problem.
All right. Did you want me to code it or you want to code it?
You up to you, brother. Whatever you want.
I guess
Whatever.
let me do it, but I'll follow your guidance.
Okay.
So we'll do backtrack, and then we want. Do you mind moving your cursor?
Oh yeah. I got you.
Then we'll do index number.
Okay.
10, which will be just this, right?
Yes, I think so.
Or-
Yeah.
Well, we're just defining it, so I guess.
We can define it. Yeah.
And then this one is the answer.
Yeah.
Okay. And then we're gonna say if length temp equals length number. then
That's
we're
actually
gonna
the pretty. I didn't see that, bro. That's pretty cool. What you did there, like, depending on the size of the number, that's the size of the letters you're gonna get. That's actually
yeah.
pretty. That was a nice catch. That was a nice
Thank
catch
you,
from
thank
you. Yeah.
For letter and map, it's gonna be what should we call it?
Oh yes, we have to create the map thing. Whatever you want to call it, my guy. Letters.
Letter and
Up to you.
letters,
Okay.
number, index. Okay. Believe we're fine there. For I'm gonna say for char.
Okay.
For char in letters at number.
Okay.
Number
Then from here,
index,
we gotta
yes.
do-
Okay. Then I'm trying to remember. Backtrack.
Yeah.
Backtrack index plus 1.
Yeah. Yeah.
Number temp plus char
Yeah.
ants.
Yeah. That works.
So number stays the same.
Yes, number stays the same. Yeah.
When does number change?
Number doesn't change because index is what we're using to traverse number.
But if we're going from 2 to 3, where does that happen?
2 to 3, right here. So index is gonna change from 0, 1 all the way to the length. So when we're doing 2, index is gonna be 0. When we're doing 3, index is gonna be 1. So number index number at position 1, that's gonna refer to 3, to the number 3. Yeah. That makes yeah. Yes, that makes because we're incrementing index.
So if number equals 23,
Mhm.
okay, it'll be like this: 23. We pass 23 for char in letters, number index 0, which would be this one. Oh, okay. This is gonna index. Okay. So
Yeah,
this could
this
be
thing is
2
gonna,
or 3. Okay, that makes sense.
Yeah, it's gonna traverse the number. Yes. Then we need some. So the next thing is, I think, is to create the map or the yeah. Ooh, nice catch. I forgot about that one. I forgot to cast it.
Okay, create the map, you said?
Yeah, or create. Yeah. I think you caught it.
Letters.
Letters. Yes.
It
Let me
goes-
see if I can copy and paste it from here. That way you don't have to type. Right there. We just have to turn all of these into strings. Are you liking the problem?
So far, so good. I'm glad you're kind of leading. You're leading it, not kind of. You're leading it. It's because I'm getting some good practice.
Yeah, because I was like, you know what? Today I'm gonna torture Carlos because I know you were a little bit scared of recursion backtracking. So I wanted to introduce you to this topic and stuff because I enjoy it and I think you'll enjoy it because it's really nice how all the pieces stick together and work together. Okay. So we got the letters.
I think from here we want to say ands equals this.
Yep.
But we got to okay, no, that's fine. Yes, ands equals that, and then we say backtrack index 0.
Yeah.
Number would be digits. And then we got a temp would be this. And then ands like that.
Yes.
Let me just double check. Digits gets passed in as number, length of number. We only need to change it to an integer right here because we need this to work. So we can't. Yeah, that makes sense. And then we change it to an integer. Okay. And then I guess we say return ands. Yay or nay?
Yeah, I think so. Yeah.
Let's run.
Let's run it. Let's see what happens.
No way.
Pause, bro.
No way, Jose.
Pause. Let me see if there's some Okay, there's a couple. Yeah, there's a couple in the first page.
Okay.
Accepted. Nice. Yeah, there's not many solutions. Yeah, I think that's the last one.
Someone did a phone board. Oh, that's kind of
Yeah.
All right, dude. I don't know.
I'd say submit it. Submit it.
Okay.
Submit it, man.
Submitting it.
What's the worst that could happen?
Let's go!
Let's go, bro. Damn.
Wow. Jose,
Damn.
you went crazy.
Nah. This is both of us.
You went crazy.
We work together. Teamwork.
I can't wait till I get that ability to see it. To at least what I struggle with as well is like the parameters.
Yeah, the parameters.
But it still makes sense, but it's like creating which parameters you need to put.
Yeah.
Sometimes I feel like if you add too much, you're doing too much.
Yeah.
That's just me how I feel. I don't know.
Yeah, and I think I learned about doing like backtracking. I haven't like done a bunch of like three or four. Is that you kind of figure out the parameters as you go, as you start solving the problem by hand or mentally, you know. Like oh I need a way to figure out how to do this. I probably need a parameter for that, or how to do this. I probably need a parameter for that. So yeah, and I don't know, something, but it's they're really.
You make
cool
me want to do
like,
some backtracking on my own.
Dude, it's nice.
Can't
man.
believe I'm
it's
saying
nice.
that.
It's nice, bro. I think I encourage you to explore. I think you would like it, for sure.
Wow, Jose.
Yeah,
I mean,
teamwork, bro.
Folks, let us know in the comments what you think about this solution. What did you do? Did you solve it? Did you not solve it? Did you not even do it? Are you just like me and maybe backtracking scares you? Or are you like Jose and maybe you just thrive with backtracking? So let us know what you think. Let us know how we did. Nice, dude. That's pretty nice.
Yeah. Yeah, I'm glad you liked it though. I'm glad you liked it because I was on the big sky. I was like, damn, bro, this guy doesn't like recursion
You
vectoring. Hopefully he
suggested,
likes.
for everyone, for transparency, pre-stream, Jose usually gets like the problems, and while I'm working on more of like getting the recording stuff set up, making sure our audio's working. Clearly, I wasn't doing that for a previous episode that we couldn't post, but since I'm doing like the production stuff, Jose's taking the time to find problems and whatnot. And usually I tell him, please no dynamic programming, please no backtracking, please none of that, because I not only do they scare me, but for our videos, they're gonna take a while. At least from our
Yeah.
streams, when we used to do streams, we did some dynamic programming, we did some backtracking, and usually we would only solve one, or we would only
Yeah.
solve like, right? So I personally feel like we should solve multiple problems in a stream or in a show, in which we did today. So I'm very happy we did that.
Yeah.
But I think it was a well due thing we needed to do, which was some backtracking. And I'm thankful for Jose
Yeah, for sure, man.
giving us that problem. So, what else I can say? So you feel good? I think we're ready for our final segment of the show.
Yeah. Yeah, we got some comments on our
Alright.
previous previous show that we had. Some interesting comments. Also, because they're on the last week's well, on this week's episode that wasn't that we weren't able to publish. We mentioned that one of our first viewers, I think it's First Shield, was watching the previous show. A little bit confusing, but I know Cardi's showing it right now. First Shield was there, so I just want to give him another shout out. That way he can hear it. That way he can get the call out he deserves. He was one of the first persistent viewers we ever had. He stayed with us for like a week, a month. Like he was always there, giving us tips, giving us motivation. And yeah, that stayed with us. First, he was one of the first viewers. I think he's from Brazil.
Brazil,
Sure.
I think, yeah.
Something like that. Yeah. So hey, thank you, First Shield. Just a little shout out.
Good seeing you,
yeah.
First Shield. Don't worry, bro.
Yeah.
We shouted you out in the last video, so it kind of, like Jose said, so it kind of stinks that we weren't able to get any audio for that. But yeah, this is our Q&A section, everyone. This is where we talk about any comments y'all give or any questions y'all ask. So we did have one comment from our previous, actually a couple, from our previous video, which was I'm just gonna go to it. It was this one, Code With Us, in which we did a couple problems and whatnot. Let me just quickly go back to the other one. Okay, so we got a question from ORIP_, and they mentioned for problem 1 they used a for loop to store the frequencies of each letter in an array, of using their ASCII value and subtracting 97 as index, then another for loop for getting the max of the vowels and the consonants. So Jose, I know you're the one that kind of understand this. Do you mind explaining what the correlation is?
Yeah, I got you. So the problem, this problem we did it, and I think it's first find most frequent vowel and consonant. So the way we solved it, we created a dictionary, 2 dictionaries, one for the vowels and the other one for consonant. And then we did a for loop, and we've stored the frequencies in the respective dictionary if it was consonant or vowel. However, this viewer used an array, I'm assuming, so that he used an array. And he used the indices of the array to determine the letter. So he got the ASCII table of A, value of A, subtracted 97, and I think it gave him 0, index 0. So at that specific array, index 0 represents A. So at index 0, he just kept, incrementing the frequency of A, index 1, incrementing the the frequencies of letter B, and so on and so forth. And that way he just like kept it pretty straightforward and all that stuff. And then he used another for loop, and I'm assuming he looped through the entire array that he created with the frequencies, and just figured out which one it was the highest and which ones was which one was the highest for highest vowel and highest consonant, which is pretty interesting. The way he used the indices to represent letters, so that's nice, man. That's pretty nice, pretty neat.
Thank you for commenting, RIP. We really appreciate it. We like hearing what our audience members might do on the problem. We also got Pizza over here. Good work from Pizza. And then we got a fire emoji from Alexa-X7I8T. So thank y'all.
Damn.
Thank y'all for the comments. So we really appreciate it. I think since we didn't really have a question or anything like that, we're going to quickly take a cut so me and Jose could go find a question from Reddit. We did this last the episode we weren't able to post. So we're going to just do that real quick. We'll be right back. And we're back. We found this comment or this question from r/CS majors on Reddit. We do have and recently just made an account. Literally just right now. So we got this question from, or we didn't get it, but we found it from Tap744A. Jose, you want to read it?
Yeah, it says career advice. I have recently graduated bachelor's in computer science, but I'm quite hesitant on what to do next. I'm fluent in C, C++, but there are local jobs that require other languages like C#. Thing is, I don't want to be jumping from language to language, especially because I'm thinking of going for a master's degree in data science or AI next year, and that requires Python. Any advice? Ooh, what are you thinking, Carlos? What are you thinking?
So I'm assuming, and I don't mean to assume, but I'm assuming maybe they might not have had an internship or something along the lines of that. Or it doesn't matter. They don't have a job, right? So they're looking for a job to use the skills that they have, but they're also thinking of going in for a master's degree in the future that's in data science and AI. So they just kind of want advice whether with the programming language they know, whether they should be learning Python or they should be maybe focusing on a job that our local job that they could get, but they need to switch to C#. My general advice is, if you're thinking about and you really enjoy data science or like AI and you're thinking about doing a master's degree, you know that's going to involve some Python. So you're going to need to probably learn Python regardless, if that's the path you want to go. If you don't really care for AI or data science and you're just going because it's a hot field or whatever, then why not stick with what you have locally and do what you have to do to get a job, like learning C# or something along the lines of that, right? So I don't think you should worry about, I don't want to be jumping from language to language, because that's part of, like, you know, that's part of the skill set that you should have. You should be very adaptable, you know. You should learn that sometimes not all jobs are going to require the same language, or sometimes something's going to change and you're going to have to quickly like adapt from it and learn how to use some other languages. And to be quite honest, most languages are very similar. As long as you know like the concepts, it's just syntax, right? There's advantages and disadvantages to each languages in which you will have to learn, but that's only the gaps you need to fill. The rest of the stuff is basic syntax, and it should be good. I'm speaking from experience. I mean, it's not easy. You just got to put in work, right? What I do is I look at some old LeetCode problems that I've solved in Python, and I literally just convert them to a different language. So, for example, like I want to learn Go, or I want to get better at Go. I literally convert it into Go language, right? And if I get stuck, I Google how do you do this and Go, and then I write it down, I learn it, and boom. So it's just getting some reps in, getting some experience is very good. So I think if you have that mentality, you wouldn't worry about anything like that. But it all matters if you like AI and data science, and if you know you're going in there, you for sure need to do Python, right? If you're trying to get a job right now and you see that local jobs require other languages like C# and you're not finding some with just C, then go ahead and start learning C#. So that's my advice. Jose, what do you think?
Yeah, I agree. Like depending on what you like truly want to do, right? Python, right? Like if you really want to go through that career stuff, probably just focus on Python most likely. But if your goal right now is to find a job before you get a master's, probably try to learn a little bit C sharp, some basics. Don't go full on it. C sharp enough to pass the interview, enough to get you the job, right? Of course, you're gonna have to be learning using C sharp in the job. But on the side, you can learn Python, right? Python, the libraries, all that stuff, and to prepare for your master's degree, so you can use C sharp in work and at home or something, learn something about Python, this and that, boom, boom, boom. But yeah, like Carlos said, it's mostly what you want, right? If your main goal is to get the master's, for sure, focus on Python, keep on going with Python. But if your short-term goal is to get a job, right now, because you need it, right, or you want one for the experience, right, or X, Y, and Z, learn C sharp a little bit, enough to get you the job, but on the side, focus more on Python. That way you can prepare for your master's degree, and eventually you're gonna get stronger in Python in your master's degree because you're gonna use it a lot more, right? And then the cool thing that you're gonna use it for your master's degree is because you're gonna learn Python, how to use Python for your own objective, which is data science and AI. And then C sharp, right? You learn the basics to get your job, and then C sharp, you're gonna grow stronger in C sharp because you're gonna use it a lot more. So yeah, it's just pretty much what you want, but it's like Carlos said, most languages have the same topics, the same thing, is just syntax, and they work a little bit differently. And yeah, I think that would be my advice. Yeah,
great advice. Tap 744A. Good luck, man. Don't give up. Keep doing what you're doing, right? It's just a matter of finding what you want to do, and no hate. Literally no hate, bro.
No hate at all. We're just
some good advice. Hopefully some good advice or bad advice. I don't know. But
yeah.
All right. I think that leads us to the final bits of our episode today. Jose, how do you feel? What do you think? We did good. What do you think?
I feel good, bro. I feel good. I feel happy we solved that backtracking problem. I'm happy that we got some comments too. I'm happy about the advice and the article. I enjoyed the article, dude. I feel like this a really good it was a good show. I liked it a lot. I'm happy. I'm excited. It all came apart, bro. I think it was really, really nice.
Nice. Yeah, me too. I felt really good, and I'm thankful that you showed a backtracking problem. You picked one out. Usually I would say, man, maybe not. We shouldn't do it because let's try to solve 3 problems today. But I think it was well needed. A good punishment for messing up the last episode, right? Again, we're deeply sorry for that. I know y'all look forward to our shows every Wednesday. But other than that, this episode will be coming out this upcoming Wednesday, which will be the
17th.
The 17th. So it's about a week away, maybe a week away from Christmas. So, so when y'all see this, we're probably going to be recording another episode, which will be coming out the next Wednesday. Is that on Christmas?
That's on Christmas. Yeah.
Okay, we're gonna have a Christmas special episode for everyone, okay? Christmas special. Please keep a lookout for it on Christmas Day. We're gonna get something special for that one. We need to, Jose. We're on the spot.
Yeah.
We need to come with something special.
Something.
Start prepping now. We'll prep now for something special for Christmas, okay? So hope y'all enjoy. Have a good week before Christmas, and we'll see y'all Wednesday on Christmas.
Bye-bye.
Sounds good.
Bye.
See y'all later. Shout out HEB.